So today we're going to talk about cooking up your own PaaS with Chef and Docker, and specifically we're going to be talking about Deis, which is the open source PaaS that I work on. But first I'd like to get a little show of hands from everyone in the room. Who here, and you can raise your hand more than once, who here considers yourself a developer? Okay, a lot of the room. What about operations? Okay, a lot of the same hands, okay. DevOps, I get it. Who here has deployed Docker and considers himself familiar with Docker? Okay, fewer hands, still a good deal. Who here has used platform as a service? Heroku, Cloud Foundry, right? So really that's what we're going to be talking about today. So a little bit about me. I'm, as I said, the main author of Deis, co-founder and CTO at OptimIn. I've been doing this stuff for a while, 15 years, big companies, smaller companies, startups, a lot of time spent as a freelance consultant doing primarily work on automation and specifically on deployment automation for a variety of software companies. Also an early and frequent contributor to Docker. I've been working with Docker since, since the first commits to GitHub. I was a contributor since about 2003 and been active in the community ever since. So, when it comes to Docker and Chef, I have some experience with how that sort of played out over time. So let's get right into it, right? Chef versus Docker fight, right? This is kind of how initially the industry reacted to this, and as you can see by the talk this morning, it's really a lot more complicated than that. But it is still helpful, I find, to review strengths and weaknesses of the comparable tools. So let's do that. So in the orange corner we have Chef, right? Chef is great at provisioning. How cool is that machine resource? But Knife Bootstrap alone is fantastic. Configuring services, I mean, Chef's reason for existence is a configuration management tool, so it's fantastic at doing that, as you would expect. It's also great for infrastructure testing, end-to-end automated infrastructure testing with things like Test Kitchen. Really, the tooling around that is really unparalleled. But it's also not so great at some things. Chef's not so great at packaging applications. It's not so great at deployments and rollbacks. There are deploy resources. It technically supports rollbacks. When you compare it to something like Docker, it's really not ideal, at least in my opinion. And for highly dynamic services that are popping into and out of existence on different hosts, it's really not ideal. In the blue corner, we've got Docker. Docker happens to be great at all of those things that Chef is not so great at, which is really helpful and probably part of the reason why so many of you showed up here. Packaging applications, it's the reason for Docker's existence. It is an application runtime. This makes deployments and rollbacks incredibly simple if you follow sort of the patterns for using Docker images. And it makes dynamic services and dynamic service discovery based systems possible. And that's really important when you're trying to build a platform as a service. It's also not so great at a few things. For example, persistent storage. How many of you here have worked with Docker volumes? Okay, how many of you think Docker volumes work well? Okay, so persistent storage is really an area where Docker needs to improve over time. Complex networking. Some of you more advanced Docker users may have seen a project called Pipework that allows you to do advanced things with Docker networking. But by default, with Docker, you get a virtual Ethernet interface for your container. It does NAT, IP masquerading out, so you can get access to the internet. You can turn inter-container communication on or off, and that's about it. So for, if your app or your service conforms to those rules, great, but in a lot of cases they don't. And really the big one is monolithic services. Docker, when you start using it, it really starts to enforce proper distributed systems design patterns on you. So if you have a big fat monolithic app, as many of us have had to deal with from time to time, it really forces you to break that app into different components. And that's not always possible. Sometimes you have legacy Java app that is monolithic and is going to remain so. And for those cases, Docker may not be a great fit. Now, could you squeeze it in? Maybe, but oftentimes you're better off using something like Chef. So I like to think of it as Chef and Docker together, providing what each of them is good at. Now, what we're focused on with Deis is how can we wrap these two different paradigms and these two different ways of viewing the world into something that is actually usable, that can solve business needs and make developers' lives easier. So what we've done is we've taken inspiration from Heroku, specifically Heroku's workflow around how a platform as a service should operate. And if you wrap all of that together, Chef and Docker and Heroku, you get Deis. And it is pronounced Deis. I get this all the time, so let's clear that one up. So I want to talk for a minute about what is platform as a service, just generally speaking. First of all, I think it's a terrible term. I prefer the word application platform, but we're still working on that. But a platform as a service, to me, is about one word. It's about workflow. Specifically, developer workflow. And even more specifically, it's about giving your developers a workflow that completely abstracts away underlying infrastructure. They should not have to worry about servers. They should not have to worry about chef recipes. They should not have to worry about how something is getting deployed. That's the dream of platform as a service. Developers focus on the code for the app or the service. They push it, configure it, look at logs, and then move on with their business. They don't have to be concerned with the how. And by virtue of that, something else comes about, which is division of responsibility. Now, it's very common in the world of DevOps. I saw the hands. How many of you consider yourself developers and operations? And a lot of the same hands came up. With platform as a service, the idea is that there should be some clear dividing lines between what developers are focusing on and what operations is focusing on. It's better for everyone ultimately, and I know that runs counter to a little bit of the movement here, but I want to talk specifically about what that means in the context of PaaS. So in the context of PaaS, developer owns the application. They own the code and the libraries, and they own the build and the test automation. Pretty standard, right? You're going to see this really in any organization. But in the land of PaaS, developers own a lot more than this too. They also own system packages. With something like Docker, you get to control the userland environment that your application runs in. So if you want to install libxml version whatever, the developer can control that. And that was typically an ops function. Runtime configuration. This particular application that's deployed is connected to these backing services, this database, this queue, this message bus. The developer in a platform like Heroku gets control over which backing services they're connected to. Are they mocks? Are they live? Are they in dev mode? Are they in production? Very, very different. That's typically, again, operations responsibility. Release management, being able to have an append-only release ledger and being able to roll back releases. Hasn't really been possible today with config management tools. Maybe the best you can get to is roll back to like a tag or a SHA in your Git repository. But we're talking about true bit for bit release rollbacks here. Logs and monitoring. How often do developers want access to the logs for their application and monitoring data for their application? And how often can you as ops folk actually provide that to them without providing them all of the logs, right? You got to do a lot of work to get that done. A platform as a service makes this possible, provides all this to everyone. And also horizontal scalability. In the world of PaaS, you really have to deal with apps that are by nature horizontally scalable. And if that's the case, and if the developers do have access to logs and monitoring data, why aren't they in charge of scaling that? They can be in the land of PaaS. So another way of putting this is developers should be responsible for the containers. What's in them, how they're built, how many of them there are, what's coming out in terms of logs. Everything about the containers should be the purview of the developer. So what's left for operations to do, right? Plenty. In the world of PaaS, and specifically private PaaS of the kind that we're working on with Deis, operations own the platform. all of the hosts, be they physical or virtual. Routing, traffic has to get to these containers somehow, and may have to pass through multiple layers of load balancing. Monitoring at the platform level, logs at the platform level, security, and critically, backing services. As we talked about before, not everything is a fit today for being inside a container. If you have a big Oracle RAC cluster, or I would argue a MongoDB environment, and it's servicing production data, I don't recommend you do that today in Docker containers. Rather, you should use something more traditional, like Chef, and put in place a standard DR process with backup and restore procedures and the like. Backing services are really a key area of focus for operations in the world of PaaS. Another way of looking at this, everything outside of the containers, right? That's ops purview, and there's a whole lot outside of the containers. How many of you in the audience are familiar with 12-factor? Okay, so for those that are not, 12-factor, 12factor.net is the website, is a set of best practices, 12 of them, in fact, and they are a set of guidelines, essentially, for building horizontally scalable applications. It's rules like don't write out persistent state inside of the application, because if you do, it's not horizontally scalable, because that state is now tied to a particular instance of the app. Also, things like how you should route standard out and standard error. You should always have, rather than writing to log files, you should have the processes that you run log to standard out and standard error, so the platform can aggregate those logs and present them to the developer. 12 or so of these rules. They're not terribly difficult to follow for new applications, but if you don't have a new application, it can be a little tricky to sort of shoehorn it into this model. But if you can, and a lot of modern apps can meet this criteria, you can get the benefits of a platform like Deis. So what I'm going to do is I'm going to show you a demo here. Now keep in mind that this demo assumes that you have a Deis environment set up and running, you've installed it, you've distributed the command line client to developers, developer has an application ready to go and they're ready to deploy, and so here we are, the developer experience, we're trying to delight the developer here. So let's do that. So first we're going to CD into an example Ruby application. This is a basic Sinatra app. We're going to take a look at a proc file, which defines the way that we're going to run the web type of this process. This is a Heroku construct. We're going to take a look at the main web Sinatra file, very simple. Note an environment variable called powered by. Now we're going to do a Deis create. This is really the entry point into Deis. Now you can see very quickly we have created Earthy Elephant as our application. Auto name generators for the win. And immediately we can git push Deis master. Now the SSH key was added with a keys add by the developer prior to this. But you can see we're immediately running through a Heroku build pack. And this Heroku build pack is open source, and you can customize these if you need to, but it detects the Ruby app, it's compiling it into a slug, vendoring the runtime and everything. And some of the special sauce we add is we actually build a Docker image on top of this that is based on the Heroku build pack. Because everything that we do with Deis is dealing in Docker images. So as you can see here, we're starting to push this image that we've built to a private registry. Deis comes with a private Docker registry, and we use that registry for maintaining layers, last mile layers that have configuration data. We manage the builds. We make it such that you can have this behind the firewall and also in close proximity to your given cluster. Oh, it looks like we've lost a little bit of the screen there. That's a shame. Well, what I can tell you now is that we're curling a command, and this command is going to show powered by Deis. And so the app is up and running, and you can see how fast that was. It was incredibly fast. Now what we're going to do is we're going to actually use the Deis config set command and set that powered by environment variable to Docker. Now, what config set is going to do is it's going to create a new layer on the private Docker registry and automatically version a new release and automatically deploy new containers with that new version of that configuration live. So I'm going to see here. So you can see that we created v3 of of this application, and it has the powered by Docker environment variable. So we're going to curl the endpoint again, and we can see it's now powered by Docker. And that's really just an example to show you how you're supposed to configure these containers when they're in the wild. So typically, you would use that for something like a database endpoint or any other configuration endpoint. The way that you configure Docker containers is through environment variables. Now, another thing I'm going to show you here is releases. So if you look at Deis releases, you can see that we're maintaining an append-only ledger of every modification to this application over time. So the first was when we created it. V2 was when we did our first push. V3 was when we set that environment variable. Now, I just did a rollback to V2, which took a few seconds. And you can see the rollback itself is now reflected by V4. This is incredibly valuable for developers. Developers get this ledger. They can know who changed what, when. If they break a build, they can easily roll it back. It's an incredibly powerful construct and something that's only possible when you're using an application platform like this. So you can see here we curl, and now we're, of course, back to powered by Deis. So if I could see what was happening, it would be helpful. I believe what we're going to do at this point is we're going to scale the containers, yes. So what we're going to do is we're going to say now we have our app configured, right? We're pointing it at the database. Let's scale this thing. Let's deploy more of these. The app's horizontally scalable. Let's do it. Because everything is already stored in the Docker registry, we can just launch 3 new containers. So we talk to the scheduler. We say, hey, go launch 3 new containers, and boom, we have 4 containers. And that right there that just blew past you was the Deis logs command. What Deis logs does is it aggregates all of the application logs for this application, provides them right for the developer. So you can see web.2, 3, 4, all of the logs for every application. This alone is an incredible justification for moving to platform as a service. How important is it for developers to know that there's a stack trace and have access to that stack trace without having you have to go to Splunk or Logstash to pull that information for them or have to provision access to that. And as you can see, a couple of curls and another Deis logs, and you can see not only are we getting basic events, we're actually getting request level events through both the router as well as the actual application runtime. So they get full transparency into everything that's changing. And this Deis run command is of critical importance as well. Deis run allows you to run a one-off ephemeral container against the current release of that application. Now, we just did an LSLA to look at what was in the container, but you can imagine a Deis run make test, which runs an entire test suite of the container using the mock endpoints that you might set through a config set or something like that. And there's your CI hook right there, right? So hook Deis run up, you deploy your release, and Deis run, does it return 0 from the test suite? If so, it passes. And this gives you the ability to hook up mock endpoints and the like. So how does this work, right? Well, let's spend some time with a basic architecture diagram here. So 3 main moving parts. We have the controller, which is really the brains of the platform. We have a Docker registry, which is where images are stored for the Deis cluster. And then we have 3 what we call clusters, which are basically groups of hosts that run Docker containers. Some of those Docker containers are the ones that we were showing before, things like scaling applications. And then there's also some special containers like routing containers, that sort of thing. Now, the controller is in charge of building images. So when you git push, you're essentially talking to the controller, telling it to build a new Docker image. And it's also in charge of running containers, and it does that via scheduler. Distributed system schedulers are a pretty simple concept. Basically, you tell it to run a job, a process in this case, and it will run the job. And if for whatever reason that job stops running, it will make sure, because the host dies or whatever, it will automatically restart that job on another host. So it's a very simple interface. We use CoreOS and Fleet to actually accomplish this at the scheduler layer. And it's a very, very streamlined way to run jobs and run them quickly. for a platform. Everything that you see in black, the load balancing for application consumers, monitoring, logging at the platform level, as well as backing services, are of the purview of ops, done in black for the color of ops. So let's take a look at the Git push workflow specifically. One of the key components to 12-factor methodology is the idea of build plus config equals release. If you stick to that simple workflow, you get the ability of having release management in a way that really makes sense. So we follow that model. So when you Git push into the system, we're creating a new build. A new build happens to be represented by a Docker image. We're then taking the existing config, set of environment variables really, and we're tacking that on as a last mile layer on the Docker image. We package that all up into release, in this case release v23, and then we push that to the Docker registry. And so my app v23 is there alongside v22, v21, and every other version passed to facilitate rollback. Then what the controller does is it actually tells the scheduler, hey, I need to run 4 versions of this container. Or if we already have it scaled to 8 and we're pushing a new build, I need to run 8 versions of the new version of this container, the new release. And I'm going to do that alongside the old release. And as soon as the new release containers come up, what they're going to do is they're going to publish themselves to etcd that say, I'm available for service now. I am listening on the port I'm supposed to be listening on. Please start routing traffic to me. And that is all done through etcd, which is a true service discovery daemon. Over time, what we do then is we start to garbage collect the old release containers. And we do that in a way that's gentle and in a way that doesn't interrupt people who maybe have an open request to an old container. So we're not killing it out from under you. And this is how you get to zero downtime deployments. And as you can see here, traffic is routed to the new release through routers that are a part of the cluster. So the Chefy bits, right? So we obviously have a cookbook that is open source on GitHub. I recommend you check it out. It's the Deis cookbook. We have a number of recipes. Most important is the controller recipe. The controller is really the brains of everything. Now, you'll see that we have a number of other recipes here that map to each of the components of the platform. It has a database, a cache, a discovery service, which is etcd, a logger that we've written from scratch in Go, a registry, a builder, and a router. And these all map to individual Docker containers. So not only is Deis about deploying and managing Docker containers, Deis is itself a set of Docker containers. And we happen to use Chef, and specifically the Chef Docker cookbook to manage these. How many of you have used Brian Fladd's Chef Docker? Excellent project. I recommend you check it out if you haven't already. So let's walk through an example recipe. So this is one of our simpler recipes. This is for our cache subsystem. So Chef Docker provides some nice LWRPs for managing Docker primitives. Docker image is for making sure that we have the necessary Docker image for this repository. And Docker container is for making sure that it runs a version of the container and that container is always running. One interesting feature I'll point out is under the Docker image resource, you can see the notifies redeploy Docker container immediately. This is really a useful feature. If the Docker image that you're using is updated at the public index, which they often are, it will automatically stop and restart the Docker container running the new version of the image, and it does that all for you, which is a very nice feature for managing upgrades, which is one of the tricky bits with using Docker and Chef together. So, as with any Chef, testing is paramount. We use Food Critic for linting, Chef Spec for unit tests, Test Kitchen and Server Spec for integration tests. When we set up the controller, are all the ports running? That sort of thing. And then Travis CI to kind of glue it all together with the open source project, so we know that when any pull requests are added, that we can actually merge them because the tests are passing. So again, back to this idea: Chef and Docker together. Configuration management is here to stay. It is not going away. Likewise, containers are here to stay. They're too powerful of a construct. Lightweight virtualization is too critical. But they really need to be viewed as something that's going to work together rather than as competing tools. So we really view Chef as an A+ solution for provisioning, for configuring services. Remember those backing services that aren't a real good fit for containerization today. Chef is really, in our view, the only option for that. And infrastructure testing, end-to-end test automation through tools like Test Kitchen. Chef can't be beat for that. And then, of course, Docker. It's packaging, deployment, rollback, and the ability to do highly dynamic process-based virtualization with things popping in and out, containers popping in and out of existence, hosts popping in and out of existence, and having things announcing themselves to a service discovery endpoint like etcd, rather than relying on arguably slow convergence process to sort of have a top-down policy-based impact. Dynamic service discovery and Docker are a really good fit. So let's do this, right? You guys want to set this up or what? So you guys can go home and get started by provisioning your controller. So instructions are pretty simple. You can clone the cookbook, Burks upload, knife bootstrap a controller, and that should get you up and running with a controller. We have other ways of provisioning controllers as well, but since this is a Chef conference, I thought I'd show you the Chef way. Next, you're going to register an admin user. The way it works today is the first user to register on the cluster is an admin user, and then that user can grant other users admin access. So if you're doing this publicly, we'll probably change that over time, but if you're doing this publicly, make sure you beat the automated bots on EC2 to the first registration there. And then you're going to configure a cluster. In order to actually dispatch jobs and dispatch containers and run those containers, Deis needs a cluster. And you typically will provide a cluster with a fully qualified domain name, which is the wildcard DNS endpoint for the platform. And then you're going to provide a set of hosts. And those hosts are not, it doesn't have to be all of the hosts in the cluster, but enough hosts to seed it and make sure that if one of those hosts goes down, Deis can still communicate with the cluster. So seed it with 3 or so hosts, and that should be good enough. And then in terms of auth, we use SSH today for coordination, so you'll typically be providing an SSH key that has authorization rights on the cluster. After that, you get to unleash the developers. We made it really easy for you. We have what I think is pretty nice documentation that we maintain. We take documentation very seriously. So you can just point the developers at our developer guide, and that will give the ability to download the CLI tools. All you have to provide them with is the URL for the controller, and they can do the rest from there. As far as operating Deis, so we have, I don't know how many, probably around 100 deployments that we know of this cluster out in the wild. And I can tell you some things that have sort of come up from some of the real world deployments, and putting your ops hat on here. SSL certificates, we don't do anything with SSL today, so this is kind of a roll it yourself. So you're going to want to drop SSL in front specifically of the controller. You're also going to want to configure log draining at the cluster level and also at the controller level. You're really going to want to know and just hook up the syslog endpoints. We do have some documentation around how you do this. You're also going to want to configure monitoring. Monitoring doesn't change much. I have my preference. I'm sure you have your preference for tools, but you're going to want to configure monitoring, if only so that you know how and when to scale hosts. One of the interesting things with platform as a service is the first bottleneck you're going to run into typically is memory, system memory. Applications start to consume memory typically faster than they consume CPU. I guess it depends on your workloads, but for most webby type stuff, that's going to be the case. So memory is often the bottleneck. One of the things that I've seen work well in the wild is you configure EC2 autoscalers to scale based on whatever policy you want. You can launch nodes and have the cluster grow and shrink on the fly, and one less thing for you to worry about. Contributing, so we are an open source project. Everything we do is open source. All code is open source. We're not open core. We don't have partial features. Everything is open source. And we love contributors. We have, I believe, about between the cookbook and the main project, about 40 to date, and we're always looking for more help on the project. There are 3 core developers on the project outside myself who can help you get started with contributing. We have a really simple vagrant up process to get started and to kind of get a local dev environment going. So what's next for us? Well, new scheduler, it's actually not what's next. Well, it landed in master yesterday. The new scheduler is based on CoreOS and Fleet, and it's super lightweight and something we're pretty proud of. And I can talk more about that after. We're also working on a service gateway. I talked before about how backing services, are really something that should be external to the platform. However, it's really important that developers have the ability to connect to a database that was provisioned by ops, the way it needs to be provisioned. So having a registry of services, or whatever you want to call it, you use a community cookbook to spin up a MongoDB cluster, and then you can provide Deis with a set of credentials so it can slice off bits of that cluster, username, password, and a database namespace. And those can get automatically attached, similar to a Heroku add-on model, where developers can not only spin up their app, but they can also pull out slices of services that were already set up by ops and published to this service gateway. We're also working on resource constraints. As of today, if you deploy an application on Deis, those containers are right now unbounded. All of the bits and pieces, so they can use how much CPU, how much memory they want, and that's obviously problematic for production deployment. So all the bits and pieces are there. The C groups exists. The tunable parameters are there in Docker to limit something to X amount of memory, Y amount of CPU shares. We just need to expose those and figure out how best to expose those in a way that makes developers happy as well as ops happy. And we're exploring options for that. And we're also working on platform level HA. Right now, the applications deployed on Deis are automatically highly available because the clusters are highly available and use a proper distributed systems job scheduler. However, Deis itself is not yet highly available, which means that if a host goes down that's running the Deis controller, you may lose the ability to manage the controller and issue scale commands and pull up logs and that sort of thing. So it is problematic, but it's not game over for deployed apps, right? Those stay up and running, and load balancing continues to work. So that's that. At this point, I'm going to open it up to questions. Yes?
The versions of the releases, are they mapped to Docker layers on the image? Because there's this boundary of Docker layers that's possible to put on an image. How do you?
Yeah, so the question is when a new release is created, are those mapped as Docker layers? And the answer to that is yes, although what we do is we maintain the build as a separate set of layers, and we only add one last mile layer that has the current configuration metadata. So we're only adding one layer for every release. We're not constantly tacking layers on. For those of you who don't know, there is currently a limit to how many layers you can have in a Docker image. I believe it's 127, and so you have to keep that in mind today.
So and the rollback will be then to the last image?
Yeah, a rollback will merge the last config. It basically takes the configuration at that time, re-adds it on top of the build at that time, and comes up with another layer. So yeah, it's a layered approach, and we want to keep the amount of layers small, and we want to keep them small in size. So by doing that, you speed up the time with which you can deploy this stuff. So in the demo we were seeing before with the first class chef support for containers, it was taking I don't know how long, a minute and a half, probably on best case scenario to deploy this stuff. We're deploying containers in seconds. Under 30 seconds, 20 seconds is typically average. And there's a lot of tricks we have to do that. You have to co-locate the registry with your cluster, make sure it's close by and you're not pulling from the public Docker index every time, for example. And yeah, so we're really focused on speed, but not just speed, order of magnitude speed improvement. Any other questions? Yes?
How would you use something like this in an environment where you need to move between environments where you've got the concept of a staging?
Great question.
how much of that Deis application metadata is in the repository, or is it on the local bot? So I end up having one machine that is the one that gets to
Can you ask that second question again? I didn't quite catch
So
that.
if I do an app create or a Deis app create or whatever on my box and I get a name back, is that metadata about that Git repository to that name on my box, or is it saved in a file and it's in the Git repository that when I recommit back to my shared repo with my team, anybody can?
Okay, so I'll answer the second question first. So the second question was, where is the information about the sort of application to Git repository mapping stored, I believe is the best way to put that. So when you create an application, that creates an object inside of the controller that references that application. The Git repository and the Git remote is really just a side effect that we added a Git remote for you for convenience. But you can re-add that Git remote, change it, do whatever you want. But the reference to the application is always stored in the controller. So there isn't this pollution of metadata on client developer workstations. It's just a convenience Git remote that we added for you. That's all it really is. And you can also override where you're pushing just by changing the remote. And we're also going to be introducing features shortly that allow you to use non-Git based deployment. Essentially, you can reference a Docker image from the public index or wherever else, and we can run through the same workflow, and you don't need Git on your workstation at all. As far as the second question goes, how do you integrate this into a typical CI/CD pipeline where you may have, a dev environment, staging environment, production environment? There's obviously lots of ways to slice this. The way that we view it best is keep separate clusters. Don't put containers that are dev containers on the same hosts that are for staging or for prod. That's how we separate them. So in order to make that work with Deis, you actually have to have different applications that map to each cluster. So you would have my app-dev, my app-staging, my app-prod, or just my app. And then what you get to do is you get to reference the same Docker build bits so you can actually promote applications by Docker build across the different clusters. And that's what we view as the ideal CI/CD workflow. The other side effect of this is that your dev environment gets its own set of configuration metadata. So you can point the dev environment to the dev database. You can point staging to its database. You can point production to its set of backing services. So we view that as the way to integrate this. And typical Jenkins setup may be for each environment, you would have a checkout, Git checkout that has its own Deis application associated with it. And as you're testing, you're essentially moving the same Docker image across different environments. Any other questions? Yes?
So maybe you just answered it, but I didn't fully interrupt it. If you've got a project with a number of developers that may have many different branches, multiple release branches, feature branches, etc., how does that fit into the service model that Deis uses?
So, the question is, if you have lots of developers working with multiple release branches and you have complex branching strategy, how does that work in the platform as a service model? First thing, I didn't actually cover this in the demo, but we offer a full suite of sharing capabilities. We have a first-class support for permissioning, so you can share a given application with a team of developers. We actually model Heroku semantics identically there, so sharing add username, and that user gets push access or whatever to the repo. In terms of the release strategy, we don't care how you do branching. You just push up a branch, and that's all we care about.
To follow up, I meant to say if you have a 1.0 and a 1.0.0 and a 2.0.0, actually like separate clusters or separate application containers that you want to use simultaneously, in a single project that has different branches for it, like how does that fit in with the single
So right now, the support for that is limited because we have the one Git remote. What I would say is the feature that we're going to be adding shortly, which is the ability to, rather than Git push, it's going to be a command, I believe it's going to be called Deis build, which is going to take a source Docker image, and that could be a private Docker registry or a public Docker registry, and basically promote that build on any application. And that's going to be the way that you can get to, I think, what you're describing, which is,
Like your CI sort of process kick off a build of that Docker image or the composition that base would then pick up and deploy as
correct. What we want to get to is the point where, for your CI process, you're spitting out a Docker image, and then you can just literally push that image or create a build based off of that Docker image. So you're promoting the same Docker artifact from one environment to the other, bit for bit Docker artifact. That's really the goal. Right now, the Git workflow is A, convenient, and B, models the Heroku semantics, which was our first goal, but it's not actually very difficult for us to implement the feature. We've been focused on the scheduler at this point. Yep. Other questions?
Do you have a hook for smoke tests or something else that container startup so that you protect against the case where, say, someone changes the setting and the backing service is available, so everything fails to start up properly, so that's undetected and it doesn't run? How do you put those sort of smoke tests?
That's a great question. We haven't focused on solving that problem. The question is, how do you implement smoke testing in this so you can try and prevent disasters before they occur? And the reason why that's important is because while you may be testing the build artifact, you're testing it with a set of backing endpoints that are going to change from environment to environment. So you may not want to actually promote a new version of a release unless it's proved that it can work in the context of the new basically config and backing services that you're working with. We haven't solved that yet. I can, off the top of my head, think of some ways I might do it, but it's premature to speculate. But I'd love to chat about it. Other questions? No? Sure? All right, well, thanks, everyone.